So the problem with our cart is that adding new rules requires changes to the calculation method with each new rule. Now, every change that we add can introduce additional bugs and requires retesting. Plus, we've tightly coupled our pricing logic with our cart, so that anytime we want to be able to test some new pricing logic, we have to set up a cart and actually test the cart rather than just testing a pricing rule. Ideally, we want to avoid introducing changes that cause cascades through many different modules in our application. And in this case, if there were many different things that depended on how the cart's behavior worked, then each change to the pricing within that cart could potentially cause this sort of change throughout our application. In your own applications, you're going to want to look for things that tend to be tightly coupled to many different parts of your app, and ideally you want to remove those dependencies by introducing abstractions that can separate those from different areas of the application. This is something that's called introducing seams within your app, where you can separate different parts of your application from one another. Ideally, when we're adding to our software, if it's complying to the open-close principle, the way that we'll be introducing new behavior is through the writing of new classes. And you'll find that if you follow the open-close principle, oftentimes when you're adding additional behavior or changing the way your software works, you'll be doing so by adding multiple new classes. And as a consequence, you'll typically have smaller classes. Each one is doing a very tightly focused job and following the single responsibility principle as well. The benefit of adding new classes in terms of how easy that code is to write and to design and to test is that by definition, nothing depends on these new classes yet. They didn't exist previously in your application, so none of the code that's already there knows about these classes and can have some dependency on it that you'll be breaking, perhaps inadvertently, when you change that code. Also, new classes don't have any of the baggage that your existing app may already have in terms of dependencies on infrastructure or other hard-to-test classes. So you'll be able to start fresh with this new class and make something that's very straightforward, simple, easy to design, and hopefully easy for you to test. Now, there are typically three approaches to achieving the open-close principle that I've found in my experience. The first one is really more of something that you would be able to do in a procedural programming language, and that is to use parameters. And so by exposing parameters in your application or in your class or in your function, you allow the client to control behavior via the specifics of that parameter. Now, this typically involves sending some kind of state to a function or to a class. For instance, a string that has some information in it, and based on that information, your class will behave a certain way. But realize too that you can combine this approach with delegates and lambda expressions so that it can be very powerful at actually changing exactly how the class or the function behaves and what it actually does. An example of how you can use parameters to achieve the open-close principle that I like to tell is, imagine that you have a digital camera and you've written a C# program that pulls all the files off of your digital camera and drops them into a folder on your C drive. You've decided, or I've decided, since my name is Steve, that I'm going to put all these files into a folder called Steve's Pictures. And I decided to just hardcode that into my C# program. Now, this program works so well that I decided to post it up on my blog, and a whole lot of people start to use it, but I soon start getting complaints that the pictures all end up in a folder called Steve's Pictures, and not in some folder that they might prefer them to be in, especially those people out there that aren't named Steve. Now, the easiest way for me to change my software and allow it to go to whatever folder the user wants to specify is to introduce a command line parameter where they could specify the output folder for this program. If I don't do that, then the only people that will be able to use my software in a way that they would like to use are developers who are going to have to open up that code, change the string where I set the folder name, rebuild my application, and then run their application such that it goes to whatever folder they've set. Now, if they're smart, they'll introduce a parameter. But if they don't, and there's a guy named Bob that wants to have his pictures in Bob's pictures, he could, in fact, just go in, change that one line in my C# file, rebuild it, and now he's got a perfectly usable program that always drops the pictures into Bob's pictures, and he's happy. However, the fact that he had to change the source code means that that was not, in fact, following the open-close principle. Now, the second way that we typically want to approach the open-close principle in an object-oriented programming language is to use inheritance, and specifically a pattern called the template method pattern. And we'll talk more about the template method pattern in other videos, but suffice to say that this is a pattern by which you can create the default behavior in a root class. Oftentimes you'll create a series of steps that need to be followed in a particular order. And then within your child types, you can override what each one of these steps might do by overriding that template method. The third approach, which is the one that we're going to look at now, involves composition in addition to inheritance, and it uses a design pattern called the strategy pattern. With the strategy pattern, the client code, the code that's calling the behavior, depends on an abstraction. And this provides a sort of plug-in model where the actual work that's being done is defined in a class that gets injected into the actual class doing the work. So with this particular approach, we have the implementation utilizing inheritance because it inherits from a base class or an interface, and then the client utilizes composition because rather than using inheritance itself to achieve this new behavior, it exposes a way for other classes to pass into it an implementation which it then sets on a field in its class. So now let's look at how we can refactor our pricing calculator in that shopping cart so that it has a better design and maybe conforms to the open-close principle a little bit better.